1.4 Can matter change its state? We all know from our observation that water can exist in three states of matter: solid as ice, liquid as the familiar water, and gas as water vapor. What happens inside the matter during this change of state? What happens to the particles of matter during the change of What happens to the particles of matter during the change of states? How does this change of state take place? We need answer to these questions, is not it? Effect of change of temperature. Activity. Do this. Take about 150 gram of rice in a beaker and suspend a laboratory thermometer so that its bulb is in contact with the ice, as in figure. Iron stand, thermometer, glass stirrer, beaker, ice, burner. Iron stand, thermometer, glass stirrer, beaker, water, burner. A conversion of ice to water. B. Conversion of water to water vapor. B. Conversion of water to water vapor. Start heating the beaker on a low flame. Note the temperature when the ice starts melting. Note the temperature when all the ice has converted into water. Record your observation for this conversion of solid to liquid state. Now put a glass rod in the beaker. Note the temperature when the ice starts melting. Note the temperature when all the ice has converted into water. Record your observation for this conversion of solid to liquid state. Now put a glass rod in the beaker and heat while stirring till the water starts boiling. Keep a careful eye on the thermometer reading till most of the water has vaporized. Record your observation for the conversion of water is the liquid state to the gaseous state. On increasing the temperature of solids, the kinetic energy of the particles increases. Due to the increase in kinetic energy, the particles start vibrating with greater speed. The energy supplied by heat overcomes the forces of attraction. Due to the increase in kinetic energy, the particles start vibrating with greater speed. The energy supplied by heat overcomes the forces of attraction between the particles. The particles leave their fixed position and start moving more freely. A stage is reached when the solid melts and is converted to liquid. The minimum temperature at which a solid melts to become a liquid at the atmospheric pressure is called its melting point. The melting point of a solid is an indication of the strength of the force of attraction between its particles. The melting point of ice is 2730.15 K. The process of melting, that is change of solid state into liquid state, is also known as fusion. When a solid melts, its temperature remains the same. So where does the heat energy go? You must have observed during the experiment of melting that the temperature of the system does not change after the melting point is reached. Till all the ice melts, this happens even though we continue to heat the beaker, that is, we continue to supply heat. This heat gets used up the changing the. Note, Kelvin is the SI unit of temperature. 0 degrees C equal to 273.15 K. For convenience, we take 0 degrees C equal to 273 K. After rounding of the decimal to change the temperature on the Kelvin scale to the Celsius scale, you have to subtract 273 from the given temperature, and to convert the temperature on the Celsius scale to the Kelvin scale, you have to add 273 to the given temperature. State by overcoming the forces of attraction between the particles, as this heat energy is absorbed by ice without showing any rise in temperature, it is considered that it gets hidden into the contents of the beaker and is known as the latent heat. It is considered that it gets hidden into the contents of the beaker and is known as the latent heat. The word latent means hidden. The amount of heat energy that is required to change 1 kg of a solid into liquid at atmospheric pressure at its melting point is known as the latent heat of fusion. So particles in water at 0 degrees C, 273 K, have more energy as compared to particles in ice at the same temperature. The amount of heat energy that is required to change 1 kg of a solid into liquid at atmospheric pressure at its melting point is known as the latent heat of fusion. So, particles in water at 0 degrees C, 273 K, have more energy as compared to particles in ice at the same temperature. When we supply heat energy to water, particles start moving even faster at a certain temperature. A point is reached when the particles have enough energy to break free from the forces of attraction of each other. So, particles in water at 0 degrees C, 273 K, have more energy as compared to particles in ice at the same temperature. When we supply heat energy to water, particles start moving even faster. At a certain temperature, a point is reached when the particles have enough energy to break free from the forces of attraction of each other. At this temperature, the liquid starts changing into gas. The temperature at which a liquid starts boiling at the atmospheric pressure is known as its boiling point. Boiling is a bulk phenomenon. Particles from the bulk of the liquid gain enough energy to change into the vapor state. For water, this temperature is 373 K. 100 degrees C equal to 273 plus 100 equal to 373 K. Can you define the latent heat of vaporization? Do it in the same way as we have defined the latent heat of fusion, particles in steam. That is water vapor at 373 K, 100 degrees Celsius, have more energy than water at the same temperature. This is because particles in steam have absorbed extra energy in the form of latent heat of vaporization. Solid state heat cool, liquid state heat cool, gaseous state. So, we infer that the state of matter can be changed into another state by changing the temperature. We have learned that substances around us change state from solid to liquid and from liquid to gas on application of heat, but there are some that change directly from solid state to gaseous state and vice versa without changing into the liquid state. Activity: do this. Take some camphor or ammonium chloride, crush it and put it in a china dish. Put an inverted funnel over the china dish. Put a cotton plug on the stem of the funnel as shown in figure. Cotton plug, inverted funnel, ammonium chloride solidified, ammonium chloride vapors, china dish, burner. Sublimation of ammonium chloride. Now heat slowly and observe. What do you infer from the above activity? Comment this. A change of state directly from solid to gas without changing into liquid state is called sublimation, and the direct change of gas to solid without changing into liquid to called deposition. Effect of change of pressure. We have already learned that the difference in various states of matter is due to the difference in the distance between the constituent particles. What will happen when we start putting pressure and compress a gas? Atmosphere ATM is a unit of measuring pressure exerted by a gas. The unit of pressure is Pascal PA. 1 atmosphere equal to 1.01 into 10 to the power 5 Pascal. The pressure of air in atmosphere is called atmospheric pressure. The atmospheric pressure at sea level is 1 atmosphere and is taken as the normal atmosphere pressure. Enclosed in a cylinder, will the particles come closer? Do you think that increasing or decreasing the pressure can change the state of matter? By applying pressure, particles of matter can be brought close together. Piston, cylinder, piston, cylinder, piston, cylinder. But applying pressure, particles of matter can be brought close together. Applying pressures and reducing temperature can liquefy gases. Have you heard of solid carbon dioxide, CO2? It is stored under high pressure. Solid CO2 gets converted directly to gaseous state on decrease of pressure to 1 atmosphere without coming into liquid state. This is the reason that solid carbon dioxide is also known as dry ice. Thus we can say that pressure and temperature determine the state of the substance, whether it will be solid, liquid or gas. Liquid Vaporization, condensation, gas, sublimation, deposition, solid, fusion, solidification. Interconversion of the three states of matter. Questions? Comment this.